So the double integrations are calculated for x is a to b, y is y1 of x to y2 of x. So the double integrations are right from a to b, means one is a to b, other one is y1 of x to y2 of x, f of x comma y dy dx. So here first with respect to y, next with respect to x. How can we define this integration by using a curve? Means if I take a curve, okay, so then take the 2 points, x is equal to a to x is equal to b. This is x axis, this is y axis, we know that. So we are defining the x limits on x axis, x equal to a to x equal to b, and going to the y limits, y are y is equal to f1 of x to y is equal to f2 of x, otherwise y1 y2. Okay, so then y is a curve defined in terms of x. Okay, so then this is our required region to find the integration. Okay, so for example, if both the limits are constants, x limits are 0 to 1, y limits are 0 to 2. Okay, so how can we define in the two quadrant system? We can define x limits are from 0 to 1. X equal to 1. This is called ordinate, x equal to 1. Okay, parallel to the y axis. Okay, if you draw any ordinate to the x, that must be parallel to the y axis. Okay, then same, y is equal to 0 to 2, y is equal to 0 because this is the origin, so x 0, y 0, y is equal to 0 to 2. So again we can draw the ordinate at y is equal to 2. So this is our required region to find the integration. If both are constant limits, we get a rectangle or square or any other shape. Okay, so but if it is a curve, we get curve equation depending on the curve equation. So for example, x is equal to 1, it's a straight line, we know that. Okay, then x is equal to y, so it's a straight line passing through the origin. Okay, and x is equal to y square, x is equal to y square, or y square is equal to x, it's a parabola passing through the origin, and x plus y is equal to 1, straight line passing through the 1 comma 0 and 0 comma 1. So depending on the curve equation, we can find the limits to the region also. Okay, so we generally use parabolas, straight line and circle. Okay, so going to the circle, what is a circle equation? We know that x square plus y square is equal to 1 or r. Okay, so x y. For example, I need to find the integration for only the first quadrant, part of the circle in the first quadrant. This is our region. So here how can we take limits? And one more thing, from the curve you need to take the limits, means one limit must be constant limit, another limit must be variable limit from the equation. Okay, so if I fix the x equal to 0 to 1 because the radius is 1, r equal to 1. Okay, and what are the limits for y? On x axis y 0. Okay, y to the curve y is equal to under root of 1 minus x square. Okay, so if given limits are constant limits, you can follow the order of the given integration dx dy or dy dx. Okay, otherwise if you want to find the limits to the given region, you can must be write one fixed limit. Fixed limit means constant limit. one is a constant limit, one is a variable limit. Then only we can get the exact region value. Otherwise what we have to, here there is a option to the y also 0 to 1, no? In case of, if you take x 0 to 1, x 0 to 1, y also 0 to 1, you get the total region. It's a square, no? Here it is, the point is 1 comma 1. It's not exact value of the integration. Don't take, both are constant. One must be variable limit, one must be constant limit, because variable limit is taking from the given equation. So that's why we get the exact region value. So that is the reason to take the limits. One is variable, one is constant. Okay. Evaluate integral 0 to a, integral 0 to b, x square plus y square dy dx. So both the limits are constant limits. If both the limits are constant, you can follow the given order of dy dx or dx dy. Okay, here given order is dy dx. So that's why first limits given for the y. Here y is there, you can give for y. Next x. So that's why we can integrate first with respect to y. So x equal to 0 to a. We are integrating with respect to y means x is constant. Okay. Then x square into integral dy is y plus y square integration is y cube by 3. Limits are 0 to b. Okay. Into dx. Now we can go for substituting the limits of y. Upper limit is b, x square into b, b cube by 3, and the lower limit becomes to 0 into dx, because here 0, x square into 0, 0, plus y cube by 3, y value 0. So total lower limit is 0. So then integral x equal to 0 to a x square b plus b cube by 3 into dx. Now integrate with respect to x. Here b constant, x square integration is x cube by 3. And here b cube by 3 is constant, integral dx is x. Limits are 0 to a. Now we are substituting the limits for x. So b a cube by 3 plus a b cube by 3, because here x is there, so that's why you can substitute a in x. It is a b cube by 3, and the lower limit is 0. So from the upper limit, what is the common value? A b by 3 is a common value. A b common. So then the remaining is a square plus b square. So always you can remember, if the limits are constant, okay, you can follow the given order for the integration dy dx, or dx dy you can write for first x, next y. Okay. How can we take the limits for this? So these limits are x to root x. So we already discussed y is a function in x. So x limits are from x to root x given for y. Remaining limits are x. Okay. Now you can, don't check this dx dy. Okay. Whatever dy dx or dx dy. Now we are following the integration by using the limits, because the limits are, one is variable, one is constant. So that's why these limits are for the y. So first always you can finish the variable limit integration, then we can go for the constant. Okay, then only we can get the value for the integration. This is a very important rule for integration. If one limit is in variable, okay, so then it is right integral x is equal to 0 to 1. First with respect to y, x square is constant, integral dy is y plus y square integration is y cube by 3. Limits are x to root x into dx. So then integral x equal to 0 to 1. We have two limits, x to root x. Upper limit is root x. Substitute for y. So x square into root x plus root x whole cube by 3 minus lower limit is x square into x cube plus x cube by 3 into dx. So now we are simplifying it. Integral 0 to 1 x square into root x power 2, x power 1 by 2, x power 3 by x power 2 plus 1 by 2, 5 by 2 plus here it is x power 3 by 3 minus x cube minus here it is x cube plus x cube by 3, 4 x cube by 3. So directly we can write 4x cube by 3 into dx. Now integrate with respect to x. X power 5 by 2 plus 1, 7 by 2 by 7 by 2. Next 1 by 3 into x power 5 by 2 by 5 by 2 plus minus 4 by 3 into x power 4 by 4. Limits are 0 to 1. Okay, so here 4 cancel and write the reciprocal 2 by 7 and upper limit is 1. 1 power 7 by 2, 1 plus 1 by 3 into 2 by 5, 1 power 5 by 2, 1 minus here 1 by 3, 2 by 7 plus 2 by 15 minus 1 by 3. So the answer is 3 by 35.